Although the stimuli needed to study the masking of pure tones by pure tones are simple, such masking experiments they have many difficulties, especially at medium and higher levels of the masker. In this picture here, we can see the threshold of a test tone as a function of its frequency when masked by a 1 kHz masker at a level of 80 dB. As in all the measurements described in the preceding sections, the subject responds as soon as the presence of the test tone produces some sensation in addition to the sensation of the steady-state masker, so the detection of anything. An effect that appears to be quite dominant in the case is that the beats are audible when the frequency of the test tone is in the neighborhood of the 1 kHz masker. So for example, a test tone presented at a frequency of 990 Hz and a level of 60 dB produces a beating quality at 10 Hz. The subject listening to such a beating tone hears something different from the steady-state masker and therefore responds, although the criterion is very different from hearing an additional tone. Considering the whole frequency range from 500 Hz to 10 kHz, it is clear that the beating becomes audible in two regions around 2 and 3 kHz in addition to the region around 1 kHz. In addition to the problem of beats, another difficulty arises for inexperienced subjects. At test tone frequencies near 1.4 kHz, the subject indicates audibility of an additional tone at a relatively low test tone level of 40 dB. A careful examination of these results and discussions with experienced subjects show that inexperienced subjects do not hear the test tone at the frequency and level, but a different tone near 600 Hz. This different tone is produced through nonlinear distortions that originate in our hearing system. The threshold of this difference tone is not the threshold of the test tone we are seeking. The test tone with its appropriate pitch is only detected at levels above about 50 dB. Only experienced subjects can differentiate between the threshold of the different tone and the threshold of the test tone. To explain this complicated situation, different regions are outlined in this figure. They are marked with indication of which sounds I heard by the subject. So below threshold in quiet of the test tone, nothing but the masker is audible. Below about 700 Hz, increasing the level of the test tone above the threshold in quiet produces a region in which the masker tone and the test tone are audible. So we have the masker tone plus the test tone. At frequencies between 700 Hz and 9 kHz, the 80 dB 1 kHz masker produces a region in which only the masker tone is audible, even though the threshold of the test tone in quiet is much lower. Areas of audible beats are marked here with this hatching. The region in which only the masker tone and the difference tone, but not the test tone, are audible is marked by steepening. Above masked threshold of the test tone at frequencies between 1 and 2 kHz, difference tones are also audible. All these results indicate that the threshold of tones masked by tonal maskers are far more difficult to measure than the thresholds of tones masked by noise.